Okay, in 22, they've given us a function, f of x, which is k times x over x squared plus 1. Rational function, k is some constant. So for what values of k, if any, is f strictly decreasing on this interval from -1 to 1? Okay, so what makes a function decrease? Its derivative has to be negative. So we are going to find f prime of x. And to do that, looks like we're going to have to use the quotient rule. Bottom, which is going to be x squared plus 1, multiplied by the derivative of the top. And the derivative of k times x, that's a linear function, is just its coefficient, which is k. That was an ugly k, sorry. So that's bottom times derivative of the top, minus the top, which is going to be kx, multiplied by the derivative of the bottom. And the derivative of x squared plus 1 is 2x. So I'm going to put a 2 right there, and with the other x, that'll become an x squared. Okay, all over our denominator, x squared plus 1 squared. And we want to know here, everybody, for what values of x is this derivative going to be negative, going to be less than 0. So I tell you what, even though I wrote that correctly, let's go ahead and set it equal to 0 for a second. The very first thing I would do is multiply the denominator over here, but times 0, that just cancels out. So we're going to end up with, and I think I'm going to go ahead and distribute this. We're going to end up then with, let me distribute this k in here, and we'll get a kx squared plus k minus 2kx squared. Got it? We want to know when is that equal to 0. And we want to try to solve this thing for k, which is kind of interesting. First thing I notice, two like terms here. That's a 1kx squared minus 2kx squared. So that's going to give me a k minus kx squared. We'll set that equal to 0. And now I think I'm going to factor out that k and get a 1 minus x squared is equal to 0. Okay, this is interesting, guys. And then from there, we're trying to figure out what values of k would make this derivative here negative. So I was thinking we would actually go ahead and solve this right here, but it looks like the only times, that gets a little bit tricky. So I think at this point, maybe we're going to start to think about what some of the answers are and look at the problem here that way. We want this derivative right here, we want this the numerator of this derivative here to work out negative. So if we were to think about a couple of cases right here, and we're just looking here, guys, in between -1 and +1, okay, I think what's important now is that for any values that we're putting in here, and notice, guys, those are parentheses and not brackets. So we're putting in an x value greater than -1, less than +1. So let's just think for an example, if we put in a number like 1/2, 1/2 squared would get you 1/4, 1 minus 1/4 would be positive. All right, that means, and in fact, that's going to happen for any x value that you put in right here in between -1 and 1. What I'm saying, guys, is that this factor right here is never going to be negative when we're dealing with these x values right here. So the only way for this product, k times this binomial right here, to actually be negative, if this factor can't ever be negative, the only way this can happen is if this factor is negative. So I'm looking at this, guys, and for 22, I'm pretty sure that the answer here is A, that the only way this derivative right here can ever be less than 0 is if k itself is negative, because 1 minus x squared will never be negative. It'll always be positive for x values in between -1 and 1. So yeah, that's it, guys, and our answer for number 22 is A.